So we're going to be discussing liquid volume and measurement. First thing we want to mention is what you typically measure with. Now, there's a few other instruments you could use, but in general, we're going to be using graduated cylinders and beakers. Now, these do come in different sizes, so one of the main purposes of talking about how you measure today is the fact that if you take a look here, these go by 2s, 2, 4, 6, 8. These go by 10s, 10, 20, 30, 40. This beaker happens to go by 20s, 20, 40, 60. And this beaker happens to go by 50s, 50, 100, 150, 200. So because you have different sizes, you need to be able to clearly figure out how much each line is worth. So when you do have a volume measurement, you can correctly estimate what is the volume between the lines. So when you do have a container full of liquid, we need to make sure that you know how to measure the right way. So the first thing we want to say, you probably heard about this in middle school, is make sure that you always read at the bottom of the meniscus. Now, in case you're not clear, the meniscus is the curve that's created when water is inside one of these containers. If it's a very skinny container, then you're going to see a really pronounced curve like this. If it's a wider container, the meniscus is going to look more like a bubble. But either way, make sure that you measure to the bottom of the meniscus. That's where the majority of the water is, and that's where you're going to get the best reading. Now, when you are reading that, also make sure that you read at eye level, which means that you're looking straight on and looking at the bottom meniscus from the edge. Don't look from above or below. So many times you might have to actually kind of hunker down when you're in the lab to look at it straight on. So now it's time to figure out how much each line is worth. Remember, as you have different sized beakers and different sized graduated cylinders, the lines are going to be worth different amounts depending on how large or how small everything is. So the first thing that you should do is figure out the difference from one numbered line to the next. So from 400 to 500, I think that's pretty clear. The difference between those two lines is 100 milliliters. Now that we know that those are 100 milliliters apart, we need to figure out how much each line is worth by seeing how many lines does it take to go 100 milliliters. So starting at the line down here, that's 0, it takes 1, 2, 3, 4, 5. It takes 5 lines past the 400 to go 100 milliliters. Last step that you do then is simply divide the difference by the number of lines. So the difference is 100 milliliters divided by 5 lines means that each line is worth 20 milliliters. Now that you know how much each line is worth, you can start making a good estimate. So if we put some numbers on here for you, we know that's 20 milliliters per line. Therefore, this we already knew, that was 400, that's labeled, but that means the next line is going to be 20 milliliters more. So that's 420, 440, 460, 480. So taking a look at this example, we can see it's clearly between 460 and 480. Now it's less than halfway, so we know it's less than 470. So basically we just need to make an estimate. We know it's 460 something. So good estimates there would be, if you think about it, maybe 462, and we've underlined the value that's an estimate because we don't really know that it's 462. This is an educated guess, but we know it's close to the real value. Someone else may think it's a little bit higher, might think it's a 463, and someone else might think that it's a 464 milliliters. These are all good estimates. They're better than just saying 460 because you know it's between 460 and 470. And so you're trying to make a more educated, more precise measurement by taking a look at these estimated values. Now, if we take a look at some class examples here, now these are drawings where the meniscus is a little bit easier to see. And in the first example, we have from 40 to 50. So again, we need to say what is the difference and how many lines does it take to get there? Well, the difference between this is obviously 10. And if you count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines to get there. So that's 10 milliliters of difference divided up into 10 lines. So you should be able to see that that's going to be 1 milliliter per line. And if we go ahead and number those, then you've got 40, and we can work our way up to 43. We could go further, but we're only kind of worried about the parts that we're looking at here. And so we know that it clearly makes it past 40. It clearly makes it past 41, but it is not quite to 42 if we read the bottom of the meniscus. So therefore, we're going to say, hey, It's 41, it's over 41 and a half. So what's something that's between 41 and a half and 42 that this is pretty close to? And so the estimate I made was about 41.8. If you said 41.9, that would be acceptable. If you said 41.7 milliliters, that would also be fine. We're going to give you a range of reasonable numbers. For this next example, we have from 6 to 7. So that's a difference of 1, but how many lines does it take? In this case, it takes 1, 2, 3, 4, 5 lines. So a difference of 1 milliliter divided by 5 lines gives you 0.2 milliliters per line. So that means that each line is going to be worth 0.2. So you start out at 6 down here, then you have 6.2, 6.4, 6.6, 0.8, and finally 7.0 there at the top. So down here, we know it's definitely 6.0. Here's 6.2. It's somewhere in between. We know it's more than 6.1. If I was going to be a little bit harder on you guys, I'd say 6.1 what, but we're just going to go ahead and estimate and say you can either estimate it at the 6.1 or 6.2 milliliters. I went ahead and did 6.1 approximately. For this last example on the screen, we've got from 20 to 25. So that's a difference of 5 milliliters, and it takes 1, 2, 3, 4, 5 lines to get there. So 5 milliliter difference divided by 5 lines in between the numbers means, again, you've got 1 milliliter per line. Now, this one's a little bit trickier for some folks because if you take a look, it hits, well, actually gets past 20, it gets past 21. It doesn't get past 22, but it gets exactly to the 22. If it was a little bit above, I might say 22.3. If it was a little bit below, I might say 21.7. But what if it's exactly on the line? We still want an estimated digit. So if it's 0 past the line, then your estimated digit there would be 22.0. We still want an estimated digit, even if that estimated digit is 0, because it is exactly on the line. Try to remember that because that does trip some people up. So in these examples, these are actual pictures instead of drawings. So here we've got a very narrow tube. The meniscus is pretty pronounced. Remember, you don't measure at the top, you measure at the bottom. In this much wider beaker, you don't see much of a meniscus, so you'd have to look pretty close. Here you can kind of measure. Technically, it's a little bit at the bottom, but you can't see a very clear difference here. This graduated cylinder happens to be kind of in between these sizes, so you see it almost kind of looks like a dark line at the top. Remember, don't measure at the top. We are measuring at the bottom. So these are just 3 examples of where you can clearly see the meniscus, where it's a little bit more difficult, but you can make the distinction. And then over here, where you don't really see it at all. So make sure if you can see it, read at the bottom of the meniscus. So looking at these numbers, we have 21 to 22. So that is a difference of 1. And it takes, I know the lines are a little bit difficult to read up here, but it takes, starting at 21.0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 lines to go 1. So 1 milliliter divided by 10 lines gives you 0.1 milliliters per line. So if we number those, that's 21.0. We go up 5 lines, is 21.5, and here you have 22.0. So what would you say that this reading is? We got 21.5, 21.6. This would be 21.7, and then it's up to you. Does it look like it's exactly at the 21.7, or does it look like it's a little bit underneath at the 21.6 something? So I would take a 21.70. If you say it definitely hit 21.7, it's exactly on the line, then it's 0 past the line. But if you think it's a little bit below the line, then you say get to 21.6, but not quite to 21.70. So that'd be 21.69. Again, estimate between the lines. For this next one, we have from 60 to 80. So that is a difference of 20, and it takes 2 lines to get there. So 20 milliliters of difference divided by 2 lines means that each line is worth 10 milliliters. So if we take a look, we have 60, then this one must be worth 70, next one was worth 80. So this is actually somewhere between 70 and 80, so it make a good estimate. If you read it at the very top, you might say 75, but if you read it just a little bit underneath, where you say there's a little bit of meniscus that you can see, I think a slightly better reading might be a 74 just a little bit less than halfway. So my estimate for this would be 74 milliliters. Now, if you said 75, you'd be close enough, and I would count that right because remember, this is an estimate. We're trying to get close to the precise value, but we do not know it for sure because if it's 71, 2, 3, 4, those little lines are not marked. So we're looking for a reasonable estimate. And then finally, on this last example of a real life picture, you have it from 40 to 50, so the difference is 10, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines to go 10 milliliters. So that means easy math, 1 milliliter per line. So that means we start out with 40, and you notice how sometimes it's a little bit longer about halfway through, so you know that's going to be 45, and then the number up here is going to be 50. So we have 45, we have 46, we have 47. I think we can all agree that it makes it to the 46, but it does not make it to the 47. So how far in between? If you're reading the top of the meniscus, you might guess 46 and a half. But remember, when you read the bottom of the meniscus, so it's a little bit less than 46 and a half, you might estimate 46.1 milliliters.